Welcome to Graphing Piecewise Functions. After this little session, students will be able to graph the absolute value function and the greatest integer function, write a piecewise function rule for a graph, identify characteristics of a piecewise function, and use a piecewise function to solve a problem. So let's take a look at our first piecewise graph. One thing we have to realize about these graphs is that they are separated by something called fences. So let's write our first fence here. I'm going to go ahead and pick a little handy dandy colored fence right here. And we can see where the fence is. If you copy this problem down, this right here kind of tells you where the fence is. Here and here. It just so happens that the fence is at the same spot of -4. So I'm going to go to -4 on the x values here. And then I'm going to make my fence. You can do this any way you'd like with uh, your ruler or something of that sort. Let's do this. And we're going to make a fence right here. Now I need to look at both sides of the fence. On one of these fences, you can see that we're going to write the equation 3x plus 2. That means it's going to be on the left-hand side of the fence. Isn't that nice how it tells you which side? Of course it's nice. So let's go ahead and find the mystery point here of, mystery line of 3x plus 2. Now, as you know, this is your y-intercept, so I'm just going to put a temporary y-intercept right here. And then from there, do what the slope tells us to do. We're going to go down 3, 1, 2, 3, over 1. Down 3, oops, I lost my spot. Down 3, over 1. Down 3, over 1. Down 3, over 1. Down 3, over 1. So let's extend our line right here. Again, what we did was take the y-intercept, go down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1. Now we actually get to start drawing the graph because we're just going to draw this from the left of x equals -4. So take a look at the symbol. That is less than or equal to. So that means I get to fill in with the closed circle right here on -4 and then get to graph the other coordinates. And we'll take out our nice little straight line right here. And this will be the part of the graph that represents, this is going to go on forever, that's going to represent this everything less than or equal to -4 on this side of the fence. 3x plus 2, this is the equation of the line 3x plus 2 on this side of the fence. Now on the other side of the fence, we have to write f of x equals -4. Now remember, f of x is equal to is the same thing as y, so this is really going to be y equals -4. And remember, y equaling -4 is a horizontal line through the y-axis at -4. So go to the y-axis and go right to -4 here on the y-axis. By the way, that's x and this is y. Whoops. And we're now going to take a look at this little point right here, y equals -4, and we're going to draw a line right from here over to represent that idea of y equals -4 to the right of -4. So this here is going to be y equals -4. Now this is going to be an open circle because it does not include -4 for this part of the graph. Which makes sense because you can't have both these occupying the same spot. This is your first piecewise function. Let's take a look at another one. Where is our fence? Well, our fence is right at -1, so we're going to draw a little handy-dandy fence right at -1. That is our fence. And now we're going to go ahead and write our equations. It would probably be a good idea to write our equations where they belong. Y equals -3 to the left of -1, so we're going to write here just for giggles, y equals -3. That's our function over here. And on this side, it's going to be y equals -x squared plus 4. So let's do this left side first. Let's go to y equals -3. Let's see, this is 1, 2, -3. And we're going to put a closed circle here and then shade all the way, or excuse me, draw all the way to the left. Now the other side of the fence, we're going to have to draw this graph of y equals -x squared plus 4. Remember from the last section is that we get to actually choose what values we get to plug in here. So let's do that. My x values are going to have to be to the right of my fence. So how about plugging in 0, 1, and 2? And how about 3 for fun? What do you say? So let's plug all these in. 0 squared is going to be 0 plus 4. Plug in 1. 1 squared is 1. Take the opposite of 1. That's -1 plus 4 is 3. Plug in 2. 2 squared is 2. Opposite of 2 is, excuse me, opposite of 4 is -4. -4 plus 4 is 0. And now let's put in 3. 3 squared is 9. -9 plus 4 is -5. And let's graph these points. 0, 4. So 0, 4. 1, 3. 2, 0. And then 3, -5. Remember, this is a parabola. So we've got a question here of where does this thing stop? Well, guess what? Let's just plug in -1 here and see what happens. -1 squared is 1. -1 plus 4 is 3. So I'm going to go right to -1, 3. And there is the parabola. Part of that graph. And you've now completed the second of your piecewise functions. Well, seeing how it's our third, we might want to try 3 different fences. So let's go ahead and draw those fences. It looks like we have a fence at -3 and at 2. So let's get our fence. And we're going to go to 2. That's our fence. Move it over just a bit to be kind of specific. There we go. And then draw another one at -3. So those are our 2 fences. Now let's start filling in what's in between those fences. Less than -3, we're going to have absolute value of x plus 3 to graph. For between 2 and -3, we're going to have y equals 4. And greater than 2 on this side of the fence, 5 minus x. So let's start graphing these as soon as we can. First one, x plus 3. Well, again, we're going to have to go ahead and find some values to plug in there and graph this. So let's plug in things to the left of -3, but let's also include -3 to see what happens on that line. -4, -5, and let's just do -6 for fun. So let's plug all these in. We're going to have -3 plus 3 is 0. -4 plus 3 is -1. Absolute value of -1 is 1. -5 and 3 is -2. Absolute value 2. -6 plus 3 is -3. Absolute value 3. And then let's graph this. At -3, it's going to spit out a 0, and that is going to be closed because we have the less than or equal to. -4 is going to be 1. -5 is going to be 2. And -6 is going to be 3. You kind of see where that is headed. Y equals 4. Very easy one. We're going to go to 1, 2, 3, 4 and draw the line between here and here. This has got to be open, and sure enough it is right here at -3. This has got to be closed on 2, and then we're going to graph 5 minus x over here. Let's take a look at some values to plug in. How about 4, 5, and 6? Plug in 4, you're going to have 1. Plug in 5, you're going to have 0. Plug in 6, you're going to have -1. Let's just do 7 for giggles. That's going to be -2. So let's go to 4, 1. 1, 2, 3, 1, 2, 3, 4, 1. Let's plug in 5, 0, 5, 0, 6, -1, and 7, -2. Let's plug in 3 for giggles and see what happens there. I'm sorry, 2 for giggles, and let's see what happens there. Plug in 2, and we're going to have 5 minus 2, which is going to be 3. And I think I forgot a point. Let's plug in 3, because I think that's somewhere around here. Plug in 3, you're going to have 2. So let's go to 2, 3. That's going to be an open circle. And then we're going to go to 2, 3, or 3, 2, excuse me. And there is our last and remaining function for this piecewise function. A lot of information. We're going to be practicing these all day tomorrow, and I see you in the classroom.